Numerical series 16. A tank of volume 0.05 meter cube contains a mixture of saturated water and saturated steam at 200 degrees Celsius. The mass of the liquid present is 8 kg. The entropy in kilojoule per kg Kelvin of the mixture is dash, correct off to 2 decimal places. Property data for saturated steam and water are: at 200 degrees Celsius, the saturated pressure is 1.5538 megapascal. Other data given are Vf, that is specific volume of liquid, Vg, specific volume of vapor, SFG, this is the difference between the specific entropy of vapor and the specific entropy of liquid, and SF, so this is the specific entropy of liquid. So basically here the subscript F is used for liquid and subscript G is used for vapor. So this is a question from properties of pure substance. Let's write down the other data given in the question. So that is the volume of tank, let's consider is capital V, that is equal to 0.05 meter cube. So this is the total volume. So this is the total volume of tank. Next it is given that the mass of liquid present in the tank is 8 kg. So mass of liquid let's say that is MF is equal to 8 kg. So if we see the property data for saturated steam and water at 200 degrees Celsius, the respective properties are given. So this is clearly mentioned here. So we have to refer these data while solving the numerical. Next is, so this is all about the data given in the question. So now what we are going to calculate in this question? So that is the entropy of the mixture. So that is entropy of the mixture of saturated water and saturated steam. So let's say the entropy of the mixture is S. So this we have to find out. So to get the magnitude of S, we have to use a relation that is S equal to, so this is the entropy of the mixture of saturated water and saturated steam. So that is equal to SF plus X SFG. So this is the relation which we are going to use to solve the given numerical. So see, if we use this relation, we have SF value and SFG value. So these two values are given in the question. But only the unknown term is X here. So if we get the magnitude of X, we can get the magnitude of S. So let's calculate X. So X is dryness fraction. And S is defined as the ratio of mass of vapor to the summation of mass of vapor and mass of liquid. So here we have the G subscript for vapor and F subscript for liquid. So if we get mg and mf, so we get the dryness fraction. So individually we have to calculate mass of vapor and mass of liquid. But in the question, mass of liquid is given and we have to calculate only the mass of vapor. For that, we have to use the specific volume. And specific volume of vapor we have to use. So if we have to consider the specific volume of vapor, that is equal to volume of vapor by mass of vapor. So if we mathematically write down this, so specific volume of vapor is small v subscript g, volume of vapor, that is capital V subscript g, and mass of vapor is m subscript g. So we have to use this relation to get the magnitude of mg. So it means mg is equal to Vg, capital Vg by small vg. So here we have small vg, but we don't have capital Vg. So now we have to approach towards how we have to get the magnitude of capital Vg. So again we left this expression as it is. So next we move towards the specific volume of liquid. So that is equal to volume of liquid by mass of liquid. So if we mathematically write down this, so this is small vf is equal to capital Vf by small m subscript f. So that is equal to capital Vf is equal to small vf into mf. So Vf value is given. Let's substitute it is 0.001157 meter cube per kg into mf is given, that is 8 kg. So if you solve this one, we get Vf as 9.256 into 10 to the power minus 3 meter cube. So this is the magnitude of Vf. So now let's consider the total volume of the tank. So total volume of tank is V. So V is equal to Vf plus Vg. So the total volume of the tank is given in the question, that is 0.05 is equal to Vf. So that we have calculated, that is Vf equal to 9.256 into 10 to the minus 3. So this value we have to substitute here. So 9.256 into 10 to the power minus 3 plus Vg. So if you solve this one, we get the magnitude of capital Vg. So that is equal to 0.040744 meter cube. So this is the volume of the vapor in the tank. So let's substitute this Vg in this expression, that is mg equal to capital Vg by small vg. So simply we have to put here the magnitude of capital Vg and small vg to get the mass of vapor. So mass of vapor is equal to capital Vg, that is 0.040744 by small vg, that is given in the question as 0.12736. So if you solve this one, we get the magnitude of m subscript g as 0.3199 kg. So this is the mass of vapor. So now we have mass of vapor and mass of liquid is given in the question. So we can easily get the magnitude of dryness fraction, that is x. So x is equal to mg by mg plus mf. So let's substitute the magnitude here. So x is equal to 0.3199 divided by 0.3199 plus mf is 8. So if you solve this one, we get x is equal to 0.0384. So this is the magnitude of dryness fraction. So next we have to consider the expression of entropy of the mixture, that is S equal to SF plus X SFG. So now we have all the values. So just put all the values here. So S equal to SF is given in the question. So that is, so here the value of SF is given. So just substitute this value in the expression of S equal to SF plus X SFG. So that is 2.3309 plus X. We got the value, that is 0.0384 into SFG is again given in the question. So that is equal to SFG equal to 4.1014. So this value we have to substitute there. 4.1014. So solve this one. We get the magnitude of S as equal to 2.4884 kilojoule per kg Kelvin. But in the question it is mentioned that correct up to 2 decimal places. So we can write down up to 2 decimal places. So S equal to 2.49 kilojoule per kg Kelvin. So this one is the final answer for the given question. I think this question is clear. Thank you. See you in the next video.